Hello, good afternoon, good morning to everybody joining me today. Thank you so much for dialing in for what I believe is a very timely topic. OGMP level 5 reporting with continuous monitoring is what we're going to speak about today. Before we get started though, please make sure to leave your questions in the chat window. You'll find it in your screen as a small icon with a question mark inside. So make sure you post your questions there, and then I'll be happy to get to these at the end of my presentation. Very good. Why do I say I think this is a timely topic? I think it is because a lot has changed in the, well, maybe 3 years is what I picked here. And I'm happy to give you an overview of what I think has changed over that amount of time, and then take it from there. I think overall, there is a lot of better sensing technology out there, not specifically to Sensorient's technologies, but overall, definitely in the optical methane sensor space. There's also much more data that we as solution providers can use to improve our solutions. Data from controlled release testing specifically, such as METEC, TADI, in collaboration with universities such as Stanford. And obviously what we do profit from a lot is real life deployments. Many large scale commercial deployments that we can also use to improve solutions. When I say solutions, well, there's the hardware part, the sensing technologies that I just mentioned, but obviously a big part of the complete solution offering is our algorithms, our analytics, specifically for quantification. And that's also what's important today. And again, there has been a lot of progress in both academia and in the commercial world, that just overall things have improved dramatically. And then a bit more theoretical, there is a systematic treatment of what I will detail a bit later of what we refer to as gap filling or uncertainty and sensor deployment as well, which for us combines really that knowledge combines in what we call a coverage-based sighting. And then last but not least, a lot more standardization. Yes, there has been the EPA Quad OB, ALTEC approval process that also taught us quite a lot, but also standards like an ISO standard that is being developed or CN standards here in Europe. So lots of learnings across the board that definitely we have been able to profit from in the last 3 years, and that allows me to stand here. So maybe before I continue, I must also say that lots of the credits for everything you'll see on the coming slide goes definitely to the larger team here at Sensorion, and obviously all the work that they have put in throughout these last 3 years. Very good. So this is a bit where we are coming from and why we think if all of this has improved, continuous monitoring is ready for OGMP level 5 reporting. So let me also say a couple words here about the use and the benefits of continuous monitoring as a whole, because clearly what we are focusing on today is what I marked in the left bottom in green, is the whole topic of emissions accounting or measurement-based emissions inventory creation. But there are so many other use cases and applications out there that you should not forget about, because typically they go hand in hand. I've seen very few operators who would only rely on one of the benefits of continuous monitoring and ignoring others. One very prominent example that I'll also get back to later is the advantage of achieving operational excellence. So when there is already continuous monitoring installed at your sites, it would be a shame if you do not make use of it in addition to, for example, creating your OGMP level 5 data. All right. If I had to explain on one slide and visualize that to you of why I think continuous monitoring really provides quite an advantage over periodic measurements, it would be this slide. So what you're seeing is a snapshot across a couple weeks and months from an actual midstream site. So it's a continuous time series. It's the site's emission rate, so to speak, on over a certain amount of time as we measured it. And what you can see by how much these emissions or the site emission rate fluctuates is that whether you fly a drone, let's say on October 19th or November 15th, or maybe by the end of December, does make a huge difference. In the examples we picked, which by the way were actual drone flights on those days, you would have underestimated the site emission rate by a factor 0.2 or 0.7, or you would have overestimated it by a factor of 9 if you would have used that snapshot in time to extrapolate to the rest of the year for that site. Not speaking yet of what additional errors do you introduce when you extrapolate from one site to many more that you think are representative, but are they really? We foresee, a bit high level spoken, a 5-step pathway to measurement informed reporting of site level emission rates. And it truly all starts with getting the deployment right. We call it the coverage-based deployment. And what do we mean with that? You'll see in a second, very high level spoken. It means we take the geometry of the site, but also of like the atmospheric simulations into account to determine sensor placement. So meaning numbers and locations of these sensors. So where are they installed best to give you the best performing outcome? Second step, and it goes a bit hand in hand with the first, is we as Sensorion, we can offer you 3 solutions and you can deploy them staggered or multi-layered. So you can deploy all 3 of them or just 2 or just 1. It really depends on your site's complexity and the layout, your emission profile, many things, but this is a flexibility we can provide to you. And that obviously does go hand in hand with the siting. So step 1, meaning where do we place a camera versus a fence line sensor or a close proximity sensor? Then the third step is actually generating the data, and that in a continuous fashion. In this case here, the continuous quantification is obviously the most important parameter or output. Where quantification of site level emission rates under the hood of OGMP level 5 reporting would already contain a certain gap filling approach or methodology, as well as an uncertainty estimate, which both, I think all of you who have ever gone through the effort of reconciling multiple data sets, making sure you get an idea of what to report to OGMP, like those estimations are very important, or the handling of uncertainties is very important. And then as a fourth step, you reconcile. That's what I just started already discussing with level 5, for example, from a continuous monitoring solution with your source level inventories. And then you report. Sounds super easy, and I know it's not. So please don't feel, or I hope I'm not stepping on anybody's foot here. But by using continuous monitoring, we think that allows you to come up with very defensible data. You will be able to very explicitly treat your uncertainty and also inform, in that case, OGMP or other regulating authorities about the assumed or determined uncertainty. And then in the end, create a reconciliation that's very transparent and even can showcase year-over-year improvements. Step 1, the coverage-based deployment. What does that mean? And it's really not black magic, but nevertheless, there was quite some effort we put into it. It starts with, well, you need to first understand what is the equipment that needs to be covered, and that we do together with the operator. So our customer success team typically would take a look at your site and would start discussing, well, what kind of emission sources do you have on site? Where are they located? How high are they? What is the typical emission profile you would expect from either that specific equipment or the site as a whole? And then we start adding sensors. Again, using our portfolio, can be cameras, can be fence line sensors, as in the picture you see on the right, can be close proximity. What you see in green there in the middle, it's a bit confusing with the green dots that are the fence line sensors here. You see all the emission sources being marked, and they show up green because you see here a screenshot from our internal tool. We call it the siting tool, that where green obviously means that source is covered per the number and the location of the sensors that I chosen and put at the fence of that specific site. If the coverage were not sufficient, there is a very easy telling by them being flagged in orange and red. And then obviously detailed further in a coverage score. And what I think is very handy for an operator in a time to detection. So both of those metrics are being calculated and then optimized together with you, depending on the use case. That's the last bullet point on that slide. And you'll see a comparison of two. Let's say you want to achieve LDAR, not necessarily under the European methane regulation, but let's say even in the US, you want to improve your LDAR program versus you want to monitor a site with the purpose of OGMP level 5 reporting. Those two use cases have very different requirements on sensor placement. And that has then also been taken into account in discussions with you. So keep those two metrics in mind, coverage score and time to detection. And I'm going to explain those on this slide using the two examples left and right of the slide. So first of all, what do you see on those screenshots? So it's the same site, it's the same equipment, but on the left, I put 5 sensors because truly what I was after, or let's say what the operator in that case would have been after, would have been operational excellence or improving your LDAR program, if you want to call it like that. Meaning what matters is speed. You want to know fast at a decent accuracy, is there something going on at my site or isn't there? And you want to know so per a specific equipment, not just from a whole site's perspective. Versus if you look at the right, I only distributed 3 sensors because that is more like if the use case, the main use case would have been OGMP level 5 reporting or a bit more generically mentioned here, emissions accounting. Then you can work with way less sensors because also on the other hand, speed doesn't matter. You kind of like only need that number once a year if you want so. And that is reflected in the table in the middle too, saying if you are after operational excellence, and I said speed matters, in that setting here with like based on our simulations and our atmospheric modeling, the time to detection as a median with these 5 sensors would be 3 hours. And for 90% of the cases, it would be within 8 hours. Versus same metrics on the right, you would need to wait, so to speak, 6 hours or 22. And that really allows, I think, the operator to judge a bit one against the other and makes it very tangible because we can also provide you these numbers on a per equipment basis. So you can also go in and say, well, I want to know, or I want to make sure my tanks are really covered very well. So increase the coverage metric and decrease the time to detection. But then, well, you know, the wellheads, maybe I don't care about that much. So that's a very, it's a fantastic discussion to be had, and it's always very insightful for both us and the operator. What I also wanted to get across, though, here again, if you remember one of my first slides, is it would be a shame, and I think it's not in the it's not the intention by the OGMP framework to say, well, the only thing that counts is reporting. I think what OGMP is also after is emissions mitigation. So again, just to say, I picked those 2 examples to go a bit to the extremes, but you can imagine if you were just to add even just one more sensor to the right, you would already get a decent operational excellence experience, let's say, or that would allow you to already tackle that use case as well on top of the OGMP reporting. So just to have said that, I think that's important. Very good. We would come to step 2, where I said that really goes hand in hand with the first one. So this is just to visualize how we very generically spoken would envision which of our solutions, the fence line, the close proximity, or the CUVA camera would be deployed across the value chain in oil and gas. And obviously, and sorry, I see there is a mix-up of the pictures, but obviously in the nubosphere, when we are speaking about emissions accounting, is very much our backbone, so the fence line solution. And then others are added per really your need. The more complex the site becomes, the more likely it is we will suggest and recommend to you to also deploy a CUVA camera. If you have indoor equipment, you may want to add a close proximity sensor because it's certified for hazardous zone usage, etc. All right. And then the third step would be, and there, let me go back a bit to what my colleague Felix has shown you a couple of weeks ago, but I will summarize that fairly quickly. If you want to come up with an accurate emissions inventory, we think you need to consider, or there are 3 key requirements, so to speak, on that technology. First, you need to have a high fidelity emissions estimate with a very low bias. If you would continuously over or underestimate, it clearly would falsify the reported numbers. You need to have sufficient data to reduce the statistical error. That's pretty much going back to the first slide I showed you. Continuous monitoring versus periodic. And then last, you need sufficient data such that the observed measurements, so the periods of time where the deployed technology can monitor the site and can come up with quantified values, you need sufficient data in order to extrapolate again to the rest of the year across your asset base, etc. About the first point, again, this is what I meant with just a quick summary of what my colleague Felix showed you in much greater detail. Our results from the AIDED 2025 campaign, so the METEC test site in Colorado, showed that Nubosphere is able to provide a very low bias site level emission rate of just -2.5% in that case here, and also like between 90 and 98% of the cases on a per event basis, being able to quantify within 1.5, respectively, factor 2 of the ground truth, which, yes, that's also important. If the quantification were off way more, we also couldn't quantify accurately on site. The total uncertainty of site level emission estimates, if I were to make it super easy, is made up of 2 things. The observation uncertainty, so that's pretty much how good are the emission rate estimates you just saw on the previous slide where Nubosphere stands today, and the representativeness uncertainty. That means how well do the observed emissions represent the annual emissions. And the latter, that is what can be addressed with continuous monitoring the most. That's why, again, as a reminder here, that plot, it's fair to say, though, and that's now the gap filling part that I mentioned at the beginning in this step 3, that all monitoring methods have certain gaps in time, no matter which one you deploy, because continuous monitoring may have gaps when the wind turns the wrong direction or the camera is rotating and missing a certain emission. Periodic monitors like drones or aerials have gaps simply based on the survey schedule that you hire a solution provider to fly. And that's now added to the bottom of the plot. And you have to treat these gaps. And there has been quite some research done in the past couple of years too. So this is not done by Censurin, but by universities such as the School of Mines, who is very prominent in publishing results about how this gap filling procedure then also can be applied in real life to not only keep it as a theoretical construct. So how does gap filling work? Again, very simply explained here. First, as on my previous slide shown, you have to identify the gaps. So you have to develop an understanding based on coverage and data quality too. That's important. We also kind of like throw data away that we do not trust. So you have to identify these gaps and you have to treat them. And how do you treat them? Well, you fill them, you backfill them with the historic mean of that site. It's that easy, one could say. And then you build your annual site total of the combination of the observed and the gap-filled time periods. All right, that much about the theory. Now the fun starts and we move on to real life. So I brought you 3 case studies, or let's say 2.5. The first one is from a gas processing plant, and it displays the challenge, the task at hand was to come up with accurate site totals using Nubosphere. And what you see at the bottom is the result of several months of deployment, where the left bar from all the 4 months being displayed shows the bottom-up site level estimate provided by the operator. Okay, so by their knowledge, very deep knowledge of their site, understanding the emissions, whether continuous emissions that are there in the sense of process emissions or intermediate, they came up with this bottom-up estimate. And then on the right, you see the estimate by nubosphere. Violet would be what we've actually observed, and then orange is what we added as a gap filling. And the gap filling in that case contributes to approximately 30% of the site total. But what's very nice to see, what was a great success for us to see, that even though, as you can see on the y-axis, the total site emission rates are fairly low, so we're looking at something between 0.5 and 3.5 kilograms an hour, nubosphere has been able to match the estimated ground truth very well. So that's the first case study I brought you. The second is about a layered continuous monitoring deployment. And in that case, it was a combination of 60 nubosphere, so fence line nodes, and one Kuva camera that was deployed on a compressor station. The Kuva camera specifically was used to monitor the compressors at the lower end of that site. And then nubosphere was distributed quite a bit across the site, as it was a fairly large one. We measured for 3 months, or we collected data for 3 months, and then compared, handed in the data to the operator. So it was kind of like a blind study, and they compared it against their third-party drone surveys that they had done. And the result you see on the next one. And again, if we go from bar to bar to bar, the very left just shows the drone data as provided by the third party, and how they estimated or came up the emission contribution would be from different equipment sources on that site. So you can tell, for example, that compressors 1 to 3 clearly contributed the most to the overall site total. The middle bar shows you just the nubosphere data, but only on those days that the drone was flown. That's very important, because what you see is, okay, cool. Nubosphere is very much in line with the drone survey data in terms of site total, so roughly 1 kilogram an hour. This is normalized here, so let's say 1. Definitely also within the error bars. And then if we take it one step further and look at the nubosphere data from all the 3 months, so from the entire pilot, it's very nice to see that then really you gain way more insights by using a continuous monitoring system about the actual site level emission rates and the contribution from the different emission sources, especially if there are intermittent sources on site. Those you would maybe catch, and you're lucky with a periodic survey, or maybe you don't, and then you don't know. Very good. Now, there was also a Kuva camera. And the Kuva camera on one day spotted a very large release from the venting area that actually was way far away from what the Kuva camera was supposed to monitor, the compressors at the very bottom of the site, if you remember. It was just 14 minutes long, so super short, very typical for vents. nubosphere was able to detect, but it was too short to properly quantify it. And so here, really, you can see the advantage of having a layered technology deployment, because with Kuva, you were able to not only catch it, but also to quantify it, and realize that that was quite a material contribution to the overall emissions, which is important to know for OGMP reporting. Last, from this case study, what I wanted to show you goes a bit in the direction of kind of like the Kuva case that I just showed you. So what you see at the top is the time resolved contribution by all these equipment sources as measured and determined by nubosphere. And then at the bottom, you see periodic measurements that were provided or taken by the operator or other third-party providers for specific equipment sources. They pick these. Now, if we take this interconnection valve 5 and 6, in case you can read it, it's the second one from the bottom, this violet marked emission source. They took that measurement at 12 o'clock that day. And again, very much in line with what nubosphere data would show, had a very, very minimal contribution to the overall emission the site level emission rate. Had they taken it just 5 hours earlier, let's say at around 7 a.m. that morning, the story would have looked massively different. So again, this is another nice example of where you can tell even just within a few hours, it does make a huge difference when exactly you do deploy your periodic surveys, and continuous monitoring shines light into the darkness, to speak. I'm coming to my next case study, but before I click the slide, I want to quickly give you a heads up, because that is now no longer about site level emission reporting or OGMP level 5 reporting. This is me going back to what I said at the very beginning. Continuous monitoring does offer a ton of other benefits, such as mitigating and sustainably so mitigating methane emissions across your asset base. And this is what I also wanted to show you. So changing topics here a little bit. There's unfortunately no data I can share, but I still wanted to share our learnings from the past years, and especially all these large scale deployments, whether that is Nubosphere or Kuba. There is a lot that we have seen across or over time. And I would say, if I were to make it a bit more general, with our deployments of continuous monitoring, we see a emission reduction across a large asset base and across customers of typically more than 30% in the course of the first year. What I also see again and again, and obviously that does require quite some investment on the operator side too, is when they have managed, when they have digested of how to use continuous monitoring, and that's clearly also not an easy task, they are able to adopt these learnings on newly equipped sites almost instantaneously. So whether then they increase the installed base or the monitored sites by factors even, doesn't make a big change. It almost allows them to continue on the trajectory of reducing emissions. And that is through, I think, a bit of a stepwise approach. So first you have to create awareness across teams. What is that thing that suddenly pops up on your site, especially if it's a camera? You have to improve by workflows the time to react. You have to enhance the understanding, again, of the field team. Like, hey, I get an alert. What do I do about it? And what do I see and what do I do not see? And then you have to drive proactive mitigation through targeted campaigns and translate the learnings finally to newly added sites. And one example I picked, and this was feedback we got from the operator, so not numbers that we came up with. When they went through that process, they were able to reduce the average assessment time until they knew what to do out in the field, or they could call up somebody in the field to say, hey, go check this out. They reduced that to below 30 minutes. Using Nubosphere, they reduced the average repair time to less than a day and their own workload by 50%. I think that's a fantastic achievement, clearly, for the operator, and certainly not something I wanted to not mention to you today. So please keep that in mind. And that brings me to my take-home message. Yeah, so keep it in mind. Continuous monitoring has evolved. Forget what you think you know when you knew 3 years ago. There is a lot that has changed, and we are more than happy to work with every operator also who is willing to share data or learnings or participate in test studies. But I confidently think I can say we are ready for OGMP level 5, which is why I'm also very happy about OGMP kind of like picking up that topic. They have formed a task force earlier that year to create a technical guidance document. My understanding was until the end of the year to address the usage of continuous monitoring for OGMP level 5 reporting. There is a gap filling methodology, if you remember that thank you to academia and their studies, I think has progressed quite a bit, so that now we can come up with very accurate total site level emission estimates by treating these gaps very systematically. Sensorion has by now a multi-layer technology portfolio we can offer, which clearly also allows to address some of the shortcomings. It's no longer that you have to just use and live with one technology. If you want to deploy something continuously, you can choose out of 3 if you go with us. And last but not least, to again conclude there, continuous monitoring offers additional benefits. regulatory compliance can be one, or operational excellence, as I showed you on my last slide. And with that, I'm already at the end. Thank you so much for listening in. I hope I was able to show you something you haven't seen before or heard before. And I now would be very happy to take your questions. All right. Let's see here real quick. There you go. Questions. All right. Can you please clarify the current status of the approval of continuous monitoring use for level 5 reconciliation by UNEP? Okay. I would like, first response would be there is no approval process within the OGMP framework. So that's also something I think that is different to other regulatory frameworks, but there is no such approval process. So what we are currently doing, and as I said, like OGMP is very open. I appreciate them being very interested in understanding the improvement that continuous monitoring has made. So we are providing them with any data that we are allowed to share, or that we can share any learnings. And my only knowledge about the task force, though that is very limited, because unfortunately we cannot be part of that task force, is that it has started, and again the timeline is supposed to be by the end of the year. I hope that does answer that question. Let me see. There's one more that says, which sites assets are suitable for continuous monitoring based level 5 reporting? Fair question. I think by the examples that I've shown you, those were complex compressor stations, processing plants. So clearly you can use it across the value chain, but I also want to emphasize that you can definitely also use it for very complex assets or sites, if that was where the question was hinting at. Let's see. All right. There's one, okay, about the site coverage. So one of the earlier slides that I've shown, what level of site coverage is actually required to achieve defensible level 5 reporting? Yes, maybe I missed on emphasizing this a bit. If you remember the slide with the left and right simulated deployments, and in the middle of that table, the last line in that table said the typical or targeted coverage metric. And maybe that person who asked that question spotted that for the OGMP, the emissions accounting case, I listed there just a 20 to 30% coverage. And that sounds very low. But it is to say that if in that extreme case that you're only after OGMP level 5 reporting, you just need to address this statistical error. And in our simulations, but also in the ones of academia, what you find is that 20 to 30% of the hours of a year, if you catch data from that time or from that amount of time, then your representativeness uncertainty goes down. That's why we come up with those 20 to 30%. So coverage, you can imagine, is a description of how many hours a year is that source or that site covered. So can it be monitored? And if you only want to come up with a level 5 grade reporting, then the 20 to 30% is sufficient. I hope that answered this question. Do you have any upstream clients who got OGMP gold standard? Yes, using only Sensorion continuous monitoring measurements, no periodic aircraft measurements. Fair question, and I think it goes back to a bit, well, there's no approval process, but there's also still, I think the understanding out there by OGMP members that continuous monitoring alone is not okay to be used in the eyes of OGMP, which is, I think, reworked quite a bit, but no, we don't have such a customer yet, but we do have ones that do use our data also in the upstream sector. Let me see. Can you comment on whether these 3 devices mentioned in the presentation are suitable for offshore installations monitoring? One of the easier questions, but thank you. Yes and no. 1 out of the 3 is. Why is that? Because you need an ATEX Zone 0, Class 1, Div 1 designed and certified solution, clearly. And only the Nubo Sentry, so the close proximity sensor, is designed and certified like that. And we are having exactly in mind to deploy these offshore for, again, different use cases. Can be operational excellence, but also OGMP level 5 reporting. I would say at that point it's also fair to add, probably not as a standalone solution, but there are so many things that we'll still have to learn about using continuous monitoring offshore, but then also about the data that is being collected, that I wouldn't dare to yet make a statement what we'll find. But clearly that is what customers of ours already have in mind, to deploy Nubo Sentry offshore, to also educate their level 5 reporting by having something that is there continuously throughout the year. Checking again. Let me see, is there something I missed? How does continuous monitoring support compliance with the EU methane regulation? I would say twofold. So the most obvious one, as this presentation was about site level emissions reporting, so level 5. I assume most of you do know that the EU methane regulation is heavily based on the OGMP framework, especially in the MRV, so the measurement, reporting, and verification part of the regulation. So for this part, yes, clearly continuous monitoring can be used, and there is no restriction in that regulation that wouldn't allow you to use it for that purpose. Let me just make a side comment there too. There is also the ELDAR part, so type 1 and 2 in that regulation. Also for that purpose, yes, you can technically use continuous monitoring. We have ourselves published quite some data that addresses how can our solutions actually meet these fairly low repair thresholds in the regulation of just 1 gram an hour and 17 grams an hour. But so yes, that can be done as well. And I think, let me check one last time if there is anything I'm missing. I think that's it. Let me see. I think that's it. In that case, thank you so much for again joining. I very much appreciate you taking the time. And please also let me know afterwards if any other questions come up. Yes, we will share the slides for sure. So yeah, I would really appreciate any kind of feedback. Also, if you find, have you actually thought about this or that? I'm always happy to talk. Those of you who know me, I think, know that. And so yeah, with that, I wish you all a nice rest of your day or afternoon, and hope to see you soon in person again. Thank you.